We are now joined by Ted McElveen. Ted, the stage is all yours.
Great. Thanks. And hi, everybody. I am excited to tell you some about Vern today. Our company, Vern, is helping to power the transition, enabling EV charging without grid delays. I'm the co founder and CEO of Vern, started Vern 5 years ago. And we've been long working in the hydrogen industry. And so you might be surprised to hear me talk some about EV charging. But really, the purpose of today's talk is to elevate and highlight one of the interesting roles that hydrogen can actually play, even in the EV world. So I know we've all thought for the last 4 or 5 years about maybe the battle between hydrogen and electric for transport. And here I hope to share some interesting new way to look at hydrogen as an enabler for electric vehicle adoption, helping to break some of the challenges that electric vehicles have with the chicken or egg problem in terms of infrastructure development and vehicle adoption. So without further ado, let me get into our role in helping to power the transition at Vern. As we all know, modern life really runs on electricity. This is not just in transport I'm talking about, but really everything that we do these days in the 21st century, and especially in 2025. Electricity is how we think. We've all seen the headlines and know firsthand the power demand growth that's coming from data centers and AI. How we make things with robotics and manufacturing becoming increasingly electrified across all sectors, and movement, which is why we're all here today to talk about really the rollout of electric vehicles and autonomous vehicles as well. So how much does this electricity demand actually add up? Here is a forecast, about a midpoint forecast that's from the US, from the EIA, the US Energy Information Agency. The current US's energy capacity is about 1.3 terawatts, is the size of the grid, the power on the grid today. And that needs to double by 2050, really driven by all those sectors I was just talking about: EV charging, manufacturing, electrification of industry, and increasingly data centers. So this is a massive increase in electricity demand and power capacity that the grid has to be capable of for us to really see and realize all these electrification improvements that we anticipate. The real challenge here is the power grid. The grid can't handle all this power generation demand growth. So as I was just showing on that last page, the grid capacity needs to double in order to meet this new demand. We've been building the power grid for the last nearly 100 years, and now it has to double just within the next 25. That's going to be a major challenge. And it's going to be a major challenge just because right now it takes us an incredibly long time to build new power lines. It takes, on average, more than 10 years to build new transmission lines in the US, and that transmission line build-out rate is actually slowing down. We've built fewer transmission lines in the last 5 years than we did the 5 years before that, and fewer than we did the 5 years before that. So our capacity of building new power lines is slowing. And finally, this grid doesn't come for free either. The grid is about 50% of utility bills are going to pay for all the poles and wires and not just the energy that's coming through them. So this really presents a pretty big challenge overall for electrification of industries overall, but also for electrification of transportation. So to double click on that a little bit, let's look at the electrification of heavy duty trucks. EV truck charging requires around 2 to 10 megawatts. That's a wide range, very wide range. But for a truck fleet, we see depots sized at about 2 to 10 megawatts for truck charging. That's a lot of power. That's as much power as thousands of homes, as much power as a major sports stadium. It really is a lot of electricity that's required for charging these heavy duty vehicles. And sometimes the grid can handle that without any additional upgrades. But oftentimes, it does really require a new substation to be built out, or in the worst case scenario, even a new transmission line. So I already mentioned that a new transmission line can take 10 years. New substations in California take more than 5 years to build a new substation. So that really poses a problem for the electrification of transport. How are we going to get all of these new electric vehicles on the road in the time frame and at the pace that we need them to address climate change and to hit some of these regulatory requirements that we have. This is really the problem of the day. So other companies have faced this example. This is, I'm not either of these companies here, but they've published some interesting case studies and white paper about this. There are companies that are seeking on-site power generation to avoid this challenge of waiting for the power grid. So this is a pretty interesting study or example from Prologis and Mainspring. They're using linear generators at their facility. And so these linear generators are combusting natural gas on site. And those on-site power generation is enabling them to have enough power to charge all these heavy-duty trucks. It's enabled faster startup time. They're starting with natural gas, although these linear generators can switch over to hydrogen in the future without any equipment replacement. It also provides some resilience to grid outages, which is another reason for installation. So, as the power grid goes down, they want to ensure that these heavy-duty vehicles are still able to charge and aren't as susceptible to grid blackouts. So this is, I think, an interesting example of what we're already seeing happen today. You can read a lot more about this on either of these companies' websites, but this site is 9 megawatts of vehicle charging with almost 3 megawatts of on-site power generation. So clearly, there's a need to complement the grid, not obviously completely replace the grid, but to complement the grid with some on-site power generation technologies. And we're seeing major companies begin to adopt this solution today so that they can begin their electric vehicle journey. This really brings me to what Vern is focused on and what we're providing, which is using hydrogen as a clean fuel to enable EV charging and enable this rapid EV charging. So just to start with the overall concept, we start with the fuel supply. That's a clean hydrogen pyrolysis production plant. Although, and to be clear, Vern does not own the hydrogen production plant. We can pick up hydrogen. We can pick up green hydrogen. We can pick up pyrolytic hydrogen. We pick up that clean hydrogen source. We then load it into our hydrogen distribution trailers and take it to a site for EV charging, where we have on-site generators that then can combust that hydrogen or send it through a fuel cell to create clean electricity. This enables the EV charging sites to get set up within a matter of weeks at the shortest, and certainly much faster than the many years it takes to connect to the power grid. This is really a game changer because it allows fleets to start to adopt EVs right away without waiting many years to get the power they need from the grid. Ultimately, when you do get the power from the grid, you can leave the generators in place and use them as backup power so that your fleet's not down if the grid goes down. Stepping a little bit more into this, Vern is really focused on hydrogen storage and distribution. As I mentioned, we don't do the hydrogen production. So as we see more and more hydrogen come online, as we see that costs get cheaper, we'll pick up from the cleanest and cheapest sources. This enables the customer not to have to wait for these grid upgrades. That's really the key point here that I want to highlight, and that is interesting for a lot of customers. They can get started today. It's also flexible. We can deliver power to remote locations. So you also can kind of experiment with where you want your charging to occur. Maybe you think you want a certain charging depot or a certain location for your route, but you're not sure. You could try it out. You could try out a spot with some temporary infrastructure. And if it works out well, you could then request the utility to connect in that location. It's also, finally, of course, cost effective. That's what matters for everybody in the industry is how expensive is this, and how does that cost compare with diesel? How does that cost compare with waiting for the grid to connect? And that's something that we're really prioritizing, as well as ensuring we can get that lowest cost fuel delivery to the site, sourcing lowest cost hydrogen so we can be cost competitive with alternative on-site power generation, such as natural gas or diesel, and also be a cost-effective solution for fleets to switch over. The next technology to highlight, and that really is also a game changer now, is these next generation, these novel generator technologies. So it's not the same generator technologies of the last 80 years. We're really seeing an improvement in generators just coming online. So this is a couple different technologies to mention. Our linear generators and fuel cells, both of them have substantial increases in efficiency relative to prior generations of generators. So there's a picture of a linear generator right here. It's a generator that can run on multiple fuel types, including clean hydrogen. There's also fuel cells, of course, that can run on clean hydrogen as well and achieve really high efficiencies. And by really high, we're talking in the 50s to 60s efficiency, about double the efficiency of a standard natural gas or diesel genset. All this, of course, is important because it drives down the cost relative to kind of an existing on-site power generation technology. Twice the efficiency, use half the fuel, and can save a lot of cost. And I want to be clear, we don't make the generator, but there's a number of companies that now make these hydrogen to power generators. So these are, all the big players in generator technology have a hydrogen to power generation option, as you see in some of the pictures here, as well as several new players in the industry. And this is by no means exhaustive of everything out on the market. I just wanted to highlight a few of the different options to make it clear that there are really many to choose from. So you can size the right generator for your needs. Make sure that you have enough power on site, but of course keep costs down to size it appropriately. The other thing I'll mention while I'm on this page here is you can see a couple different types of form factors here and types of generators. There's some of the more permanent installations, and there's also some more temporary ones like this Nuvera or the GM model that you can tow behind a truck and bring to the site. This is helpful for things like pop-up charging needs, where you might have a need just for a short period of time, or as I was mentioning before, you might want to try out where your power generation, where your charging location occurs before you invest in a more permanent infrastructure. So what Vern provides here is really everything I've just been talking about. We build the hydrogen storage systems, and then we use those hydrogen storage systems to deliver hydrogen to customer sites. We then also lease out the hydrogen to power generators. We don't build those, but we acquire them from the producers and lease them to various customers. So combined, excuse me, it's a full package that a customer can come to us and say they want electricity for EV charging, and we'll provide the full service, the charger, the generator, as well as the hydrogen fuel delivery and the hydrogen fuel sourcing. Our kind of legacy in the industry is focused on hydrogen storage. So that's what we actually build ourselves, is the hydrogen storage systems with a manufacturing facility in the US and Pennsylvania. So again, just back to the overall picture here of the concept, we really take hydrogen, we use it as a clean molecule, and a lot of people think of it as a fuel. We're essentially using it here as a fuel in a different way. It's a fuel to actually deliver electrons to a site to enable EV charging. In many ways, it's still replacing diesel. It's replacing a diesel generator, though, and not a diesel engine on a vehicle in this instance. So helping to stimulate the adoption of EVs before the grid connects to various locations, and then providing a resiliency and backup supply in case of a grid outage in the future. Finally, I just want to close by mentioning a few other things about Vern. For those of you who don't know us, we're really proud of all of our investors and partners that we have supporting us, from Caterpillar, Amazon, NextEra, United Airlines, Cummins, U.S. Army, Department of Energy, and Breakthrough Energy, along with many others. We've done several commercial projects, including with Volvo and United Rentals, and then finally have proven out all of our hydrogen storage technology at national labs here in the U.S., Lawrence Livermore and NREL. And last, we have a lean team here. We're still a startup. We're 17 people. We're based in California. We also are growing our manufacturing in Pennsylvania to build out these various hydrogen storage systems and containers. Great. So that is my presentation for today. I realize I moved through that pretty quickly, so I'll have plenty of time here for questions if there are any, and I can address them. So thank you, everybody, for listening today about this solution that we have brought to the market here to enable the rapid adoption of EV charging for sectors that don't have access to power from their local grid, using hydrogen as a clean electron carrier. Thank you. Great. So looking over here at some questions on the right-hand side, does your doubling of grid capacity include projects needed for AI data centers or just electrification of existing industries? includes everything. So it includes data centers and AI. There's various projections out there of how much power is needed for data centers and AI. The latest number I've seen here in the U.S. is about 12% of the grid could be, or 12% of power needs could go to data centers and AI in the U.S., up from about 4% today. So it is growing rapidly. But actually, if you look at some of the breakdown, things like electric vehicles are actually a major driver of the growing power demand. So while AI and data centers are the rapid and near-term driver, kind of EVs can be, in the long term, even a bigger impact. Do we work with rental providers? We do. So United Rentals, for example, as you might have seen on this last page here, you can work with us through working with United Rentals. So we're happy to work with United Rentals there. In that model, you can rent the generator from United Rentals, and we'll be the fuel provider. So you can reach out to them, and they'll be the one that provides the fuel cell. And so that's one way to work with us. We're happy to work with other rental providers as well, or you can work just directly with us. But United Rentals is a company that we have the pleasure of working with.
Thank you, Ted. We'll give them a couple more minutes if there's any more questions. And if not, I'm sure they can reach out to you later in the day, correct?
That's right. Yep. I've got my email address up here. So please reach out if you have any questions about how this works, the overall model, how we can specifically serve various fleets, or just about the technology in general. So ted@vern-power.com, or you can go to our website and see some more there as well.
Awesome. Well, thank you for presenting. I don't see any more questions coming in. Thank you, everyone, for joining us. Enjoy the rest of your day.
Great. Thanks, everyone.